Hello, this is Sarah Coffin, and here's my homework 2. So as you can see here, we have the Kerbal 1 stock rocket on the launch pad. Additionally, there has been placed the CX4181 scriptable control system unit right here, as per the assignment instructions, so that we can control it. Over here, we have a Ubuntu terminal that's currently connected to the telnet port, and now we'll actually connect to the rocket, so here we go. We'll switch to the archive location where the script file is, and we'll run the launch file. Alright, as you can see here, there's a little bit of logging going on. It's because the font size on the actual window is a little bit small, and so that you could have some mission logging if you so chose. An additional value here that's not tracked on this window is this 1.1 times periapsis, since that's the stricter circularity control for the assignment. So in terms of strategy for getting into a circular orbit, the first iteration of the script was a bit messy. This is actually version 2. It's much cleaner, and it was done after more research into previously done work. So for the ascent, which it's currently doing right now, as you can see, it starts with full throttle, and it's turning towards the east. The angle of turn is determined by a cubic function, or a cubic root function. Excuse me. And that's aiming to increase the actual acceleration of the orbital velocity, so increasing the horizontal speed more so than the vertical as it progresses. There is a slight bit of throttle control towards the end once you start getting up towards 45 kilometers in terms of altitude, just to conserve a little bit of extra fuel. And it's switching to the last stage. It's continuing its ascent now, and then we'll begin the circularization procedure once it reaches an apoapsis of about 71 kilometers. It's aiming for 70.7 kilometer apoapsis, but overshoots it a little bit. And then after that, it will follow a slightly modified version of a circularization script I found online by GitHub user Gufo, which actually uses the orbit's eccentricity, which is a mathematical value for the circularity of an orbit, which works pretty well in this case. The angle of thrust, I guess, or the angle of the rocket for that step is determined by an arctangent of the thrust vector and the combination of centripetal and gravitational forces. And we'll see that more once it coasts up to apoapsis, because the circularization step does not activate until it is at apoapsis. Right now it's just completing its burn, and now it's time warping to skip through the part where it just kind of floats through space until it reaches about 70 kilometers, and then it'll slow back down and begin the circularization procedure where it waits until it reaches apoapsis before actually circularizing. The speed here is only 2 times since it's still very low, and as you can see, during this there's the possibility of having slight maneuvers. If you're watching the delta V, It's currently at 899 meters per second left. And we should get to about 500 meters per second left at the end of the circularization procedure, which is beginning now. So it just hit apoapsis, and now it's moving at a slight angle to try and increase the periapsis without increasing the apoapsis too much. And now it's creating a positive periapsis and should reach an acceptable circular orbit in just a few seconds. And now that it's cut out, you can go see over in the terminal window, there's the done, there's the orbit reached, eccentricity of about 0.00078. The apoapsis is 71.3 kilometers. The periapsis is 70.28 kilometers. And that's well within the 1.1 times periapsis range. And you can see the orbit velocity of 2,293.2, which is just where it needs to be to maintain orbit at this altitude, according to the Kerbal Space Program Wikipedia docs. So, ta-da, we've made it. You can see the delta V is 503 meters per second. I will actually do a quick little snipping tool to make that a little bit bigger since it's a little bit small. So we'll open that up and see. There we go, 503. Thank you for watching, and I hope you enjoyed. Goodbye.